Hey everyone, Daniel here from the AI Automators. Today I've got a great tutorial for you where I show you how to load up your very own knowledge base of documents into your make.com automations. And when you get Claude or ChatGPT to generate articles for you, they're highly accurate and highly personalized based on what's in those documents. If you're into building AI solutions for clients, then this is a powerful technique to learn, as it can really open the door to bigger clients and bigger budgets. So in this tutorial, we'll be loading up all of this information from this e-commerce store into Pinecone, which is a vector database. And then when we're generating content, we'll first be retrieving highly semantically relevant information to dramatically improve the accuracy of the text. This tutorial is totally no code, so even though it sounds complicated, anyone will be able to do it. And these make.com blueprints will be included in our automation community, where you can quickly download, import them into your make.com account, so you'll be up and running in a few minutes. The technical name for this technique is retrieval augmented generation, or RAG. In other words, we are searching for highly relevant information that we can augment prompts when we're generating new content. This RAG style system is one of the most common use cases for businesses implementing AI, as they typically have lots of documents that they need included in generating outputs, but these documents aren't publicly accessible. Before we begin, if you're new to this channel, my name is Daniel Walsh. My brother Alan and I run the AI Automators, which is an online community where we help you automate your business like a pro. Before we dive into it, let's have a quick look at the end result. This is the online store that we're generating an article for, and I've loaded up all of the information from this online store into our vector database. And then by a simple prompt, such as generate an article based off a 20% off sale, it's able to output this highly accurate article that has images, product descriptions, accurate specifications on the products. It even has accurate shipping and delivery times, information on returns, and gift cards. So this highly accurate article was generated using this RAG-based system. Let's get started. Generally speaking, there are two stages to a RAG system. The first stage is to load up your knowledge base into a vector database. When you're gathering data, this could be crawling websites, it could be uploading PDFs, Word documents, Excel, CSV, JSON, whatever it is. Once you gather the data, you then send it into an embeddings model. In this system, we'll be using OpenAI's text embedding 3 small model. Then when you have these vector embeddings, or these numerical representations of the data in this knowledge base, you can then upload them or upsert them into the vector database. And when I say upsert, what I mean is if it's fresh data, it'll then be inserted into the vector database. Whereas if it's data that's already in the database that needs to be updated, then it will be updated as part of this flow. So at this stage, you then have a knowledge base that has a vector database that represents it. So you can then query that vector database to find relevant results. So the second stage then to a RAG system is to generate content based on a query. So step 1, we need to understand the query. So in this video, the query will be write an article about an upcoming sale for this online shop. Step 2 is then we generate an embedding of that query, again using that OpenAI's embedding model. Step 3 is then we send the query or the embedding of that query into the vector database, and we retrieve the most relevant knowledge for that query. And then we include that relevant knowledge in the prompt when we generate the content, and that could be through any large language model. It could be Anthropic's Claude, OpenAI's GPT-4o or O1, or open source models like Llama 3 or Mistral. To really hit home what this RAG system can achieve, I'm going to go through 3 different prompts. The first one is a prompt without context. So here I'm asking an LLM to write an article about an upcoming 20% off sale for a shop called Luma featuring a couple of products. If we were to send this prompt into a model, that model will have absolutely no idea about what shop this is, what products they are, and will absolutely hallucinate an answer and just try to pad out an article. So an improvement upon that is what we call contextual prompting, or at least it's manual contextual prompting. So we're asking the same question, but we're then say, base the article on the following information, and then we need to paste in manually information about the shop, information about the products, etc. So this is a brilliant prompt engineering technique to dramatically improve the accuracy of outputs from a large language model. The problem with it is it's manual. Some of the more recent models have much larger context windows. So Llama 3.2, for example, can handle up to 128,000 tokens. So roughly 100 pages of text. This context window length will most likely increase as new models come on stream, which means you can stuff lots more information into each prompt to generate accurate outputs. The problem with this is long prompts cost money, and you may end up with less accuracy as there's so much information in the prompt. It's a lot of noise for the LLM to work through to figure out what to output. So sometimes it's better to be quite refined and focused as to the information you provide the large language model to give it the best chance of producing an accurate output. So that's where RAG comes in. So with RAG, it still is contextual prompting, except it's dynamic. And what that means is it's taking this prompt, it's creating an embedding of it, which goes to the vector database to retrieve the most relevant results for this text, and then that's dynamically entered into the prompt at the bottom here. There are many benefits to this approach, The main one being you don't need to keep manually pasting in information that's relevant to the actual prompt. And if you can create a RAG system that continually updates, like what we're going to go through today, then the information that's retrieved is always up to date. And just a quick note on OpenAI assistance versus the type of system we're going to go through today. I created an AI agent video where I used OpenAI assistance, and I built a make automation to continually update the vector store and the files within that OpenAI assistant. So check out the card above if you're interested in that. It is worth discussing the differences though. RAG with OpenAI assistance is very easy to set up. So definitely if you're on the beginner scale, I would definitely start here. Using Pinecone and Make to create a RAG system is definitely on the more complicated side. If you are using RAG with OpenAI assistance, you are very much locked in to using OpenAI's embedding models and their large language model. If you're using the Pinecone approach, you can use any embedding model, you can use any large language model. The concept of using a vector database can be implemented locally, not necessarily with Pinecone and Make, which are both cloud-based platforms, but you could use FAISS, which is a local vector database, and N8N, which can be self-hosted. I've created a dummy e-commerce store that you can see here. This has about 200 products along with a host of informational articles. So what we're going to do is load all of the information on this website up into Pinecone, which is a vector database. To demonstrate this, I created a Google Sheet, which contains all of the static pages. And I've also brought in 30 different products from the store. I'm showing you a Google Sheet here, but this data could really be in any format. This could be scraped from a website. It could be a CSV or an Excel. It could be JSON files. The important thing is that you can get it into some sort of digestible format so that we can process it. So next up, we need to set up an account on Pinecone, which is a vector database. So when you go to pinecone.io, you'll be able to create an account or log in if you already have an account. You can see their pricing here. They have a free plan, which is what I use. And that gives you access to 5 different vector indexes. And you can see the various thresholds and usage limits here on that free plan. They also then have a pay-as-you-go plan if you need kind of higher limits. So once you sign up, you'll be landed into a dashboard like this, and your Pinecone account is ready to be used. So next up, we're then going to go to make.com, and we're going to create a new scenario. And the first module we're going to create is a Google Sheets module, because what we want to do is to load up all of the information on this sheet and upload it into this Pinecone database. So we'll click on Google Sheets, and for the moment, we're going to use the get range values. So just type in get, there it is, get range values. You'll then need to select the sheet. So you can choose the file, and that's it there. You can choose the sheet name. So I have created the first tab as Knowledgebase here. And then what I'm going to do is load up the range from A1 all the way through to, we'll say, M51. Again, this will be specific to however you're loading up documents and loading up information, but this will work for this approach. Excellent. So we'll press OK to that. So I just save this and run it. You'll see that it's outputted a very large number of bundles, 50 different bundles. So for the case of testing, what I'll do is I'll just limit this to maybe 2 or 3 rows. So I'll just change the range here from A2 to, let's say, M4. So we'll save that and run it again. Yeah, now we just have 3 different bundles. So we'll get the workflow up and running, and then we can expand it out to the full data set. So next up, what we need to do is create what's called an embedding. So if I jump into one of my other indexes here on Pinecone, let's jump into this one. And if I open up a record, you can see I've already uploaded a product here from this e-commerce store. And if you look down below, there's a field called text. And if I just copy this out and show it to you. So there's a quick look at the text associated with this product. So the product name, we've got a description, there's a link to the product, categories, price, whether it's in stock or not, product images, etc. So that's all of the information associated with that product. But while that data is actually stored in Pinecone, that's not what's used to provide the most relevant results. Pinecone is a vector database, so it needs numbers, as you can see here. So these decimals or vectors essentially represent the meaning of this text. So while that sounds pretty strange, this is effectively how large language models work. They embed text, plain text that you see here, into numbers, and then all of that is fed into the algorithm to figure out what's the statistically most likely next word based on a certain context. So what we need are these decimals or these vectors. So to generate these vectors, we need an embedding model. And if you go to OpenAI's platform, for example, you can see that they have a number of different embedding models to generate these types of vectors. And today we're going to be using the text embeddings 3 small model, and we're going to feed all of the information from our knowledge base into that model to generate out those numbers that we can then upload to Pinecone. So then back to make.com. So if we click on the plus icon and type in OpenAI, so what you're going to do is look for embeddings. So if you just search embeddings, you're not going to find any modules. So they haven't actually created a make.com module for embeddings. So instead, what we're going to need to do is click on the make an API call. So we press that there. And then what you need to do is just type in /v1 /embeddings. And then we're going to post to this endpoint. And then at the very bottom under body, we're going to need to put in some text. If we jump back to the OpenAI platform here, we're going to see the API reference for this endpoint. So there's embeddings. We're going to be posting to this endpoint that's there. and it's expecting this. So if we copy that out, bring it into here, let me just make some space so that you can actually see that. And then when you're hitting kind of arbitrary endpoints on make, it is always best to kind of just remove the spaces. Okay, so in this case, the text that we're looking to create vector representations of, in this case, the text is the food was delicious and the waiter, etc. We're going to be using, actually, we'll use a different model. So not the ADAS002. Let's use the text embeddings 3 small model. And we can leave encoding format as float or a floating point number, which is a decimal. Okay, so then let's press OK to that. We'll leave the text as that dummy text for a second. If we right click and run this module only, what you'll see then, we've passed the food is delicious and the waiter, etc. And then in the response, we're getting a body. And then under data, you're getting all of the embeddings that we're looking for. So let me just zoom in here. So these are all of the numbers that represents that text that we just passed in. And this is what we need to save in Pinecone along with the original text. And there's the input, the food was delicious. So now next up, let's remove this text and let's put in the text that we're retrieving from the Google Sheet. Okay, so we'll click out of that, back into here, and we'll delete out this. And then you can see the pop up here with the various variables from the Google Sheet module. And for this, we're going to look for, let's say, description and press OK. So we'll save that. And again, actually, maybe we'll just limit this to a single row while we get this scenario up and running. So A2 to M2, save that and run once. Okay, so we've encountered an error. So let's have a look at the error. So the problem here is it can't parse the JSON body. And the reason for that is the text isn't escaped properly. If we dive into this description, you'll see that there are various problems with the text. There are JSON kind of unsafe characters in it. So we need a way to escape all of this text so that it's JSON friendly and we can pass it in a call to the likes of this OpenAI endpoint. So this is kind of a major limitation of make.com at the moment. There is no native way to do this where you're using kind of dynamic text and dynamic structures. So there's a bit of a workaround that I'll show you here, and I'll drop this into the description below so you can use it in your own automation. So if we come in here and we're going to right click on that, add a module, this one will be set a variable. We'll do set multiple variables because I have a feeling we might need another one. And for this one, then we're going to name this JSON Safe string. And what we need to add in here is this. So this looks pretty horrific. This really is a workaround. But what it's doing is it's replacing all of the JSON unsafe characters with spaces, or it's escaping them so that they can be processed in the request. And then the value in black here, which references 7.3, that needs to be deleted. And you need to then drop in the description there. And then if we press OK to that, and let's run this. Let's put a filter here so I can't go past this gate. So we'll just say when 1 equals 0, which is never going to be the case. If we save that, I just want to run these 2 modules and not this module. So we'll click run once. Okay, that's run. And if you look at the first one again and click description, you'll see the initial description from the Google Sheet. But then when you click this one, you'll see that this is the new description where all of the characters have been escaped. And this can now be processed in a web service endpoint. So there's the JSON Safe string. So now let's remove this filter, come back in here. And instead now of having the description as what we're passing to the endpoint, we're going to have this JSON Safe string. So we'll click OK to that, save it, let's auto align, and let's run it. And now, as you can see, because that description has been successfully kind of cleaned so that it can be passed to the endpoint, this now succeeds. And if we press 1, we can now see that's what we passed. And then back into the body, data, number 1, embeddings, and there we have it. So this is now the vector representation or the numeric representation of this text. And there's a large range of vectors that we can now import into Pinecone to represent this information. Before we go any further, what I might do is create another variable just to represent all of the information associated with a row on this sheet. And that way we can clean that variable so it can be passed to the endpoint. So if we come back in here, I know I created a set multiple variables, but I'm just going to create a new module, which is set a variable. And then let's just say this is the full record. And then I'll just work through and populate out the values for each column. Okay, so there we have it. So go to that. And then when we come to here, instead of using the description, I'll use that new string that I just created. So full record. Okay, and then actually let's leave this filter in and run it and see now how it looks. Excellent. Yeah, so we now have the title, page link, and some of the other headings where there isn't actually any information. Okay, so we'll remove that again. And now we know we can generate a vector for a record on our Google Sheet. So next up, we need to push that vector into Pinecone, into an index. So if we click on plus and then just search for Pinecone, firstly, we're going to use a get a vector module. The reason for that is we want to search to see, does the vector already exist? And if it doesn't, we're going to create it. And if it does, we'll update it. So that's called upserting. You both update or insert depending on the context. I already have a connection created here. If you don't, you'll just need to click add. You'll type in an index name and an API key. So for this then, in Pinecone, if you go to indexes, you can create an index. So we'll call this the make automation. When it comes to dimensions, what it's looking for, if you click Setup by Model, we're going to be using the Text Embeddings 3 Small module in this case. So I'm going to click that, and that's going to load 1536 into the dimensions. Everything else I'm going to leave as is, and then I'm going to click Create Index. And then this is my index name. So when I go back into Make, I can drop that index name into there. And then in terms of an API key, you can come into here, API keys, and you can copy one that already exists, or you can create a new one. And once you do that, you can drop that API key into there. So I'll just copy what I already have and paste that in. Oh yeah, the index name needs to be based off what it says down here. So it's actually not the index name, it's based on the URL structure. So come back in here, make automation, that's the URL structure, so copy that. So you remove the end bit, remove that pinecone.io, and remove the HTTPS piece. So that should be it, I think. Press save to that. Maybe the trailing dot, get rid of that. Yeah, that's done it. Yeah, so you remove the HTTPS //, remove the .pinecone.io at the end of the URL, and that's it. I know you saw the API keys there, so I'll just refresh them after this video is finished. Okay, so now we have a connection to Pinecone. So what we're going to use as a key to check does a record already exist will be the URL. So if we come back in here, we have page link as our URL. So the idea here is we're going to look for, let's say, this URL, which is a gift guide in Pinecone, and if it exists, we'll update that vector. If it doesn't exist, we'll create that vector. So then into vector ID, and then back to that first Google Sheets module, and we'll use page link as the URL. I'm going to press OK to that. Don't need to set namespace. Next up, if we click on add another module, we'll go Pinecone. Now we're going to use that upsert vector, which either inserts or updates. You can set the connection that you just created. And then vector ID, again, we're going to use that URL, page link as it is seen there. And then in terms of values, what you need to do is click add item, click on that empty field, which will load up the variables. And then in this OpenAI module, you need to go to data, embeddings, and just click on embeddings. That's going to load that entire array of vectors into that value. Now, a key actually is to press map. I missed that because we're not creating a single vector here. We're creating an array of vectors. So we're mapping this array of vectors to this field. So now if we click OK to that, press save, and we'll run this once. So it's retrieved that single row from Google Sheets. It's created embeddings, and it's now upserted them into Pinecone. So let's have a quick look. I don't even need to refresh. It's automatically refreshed it. And there you can see it at the bottom. So let's just have a look at that. And there you have it. Yeah, there's all of the values or all of those vectors or floating point numbers that have come back from that embeddings module. Now, the only issue is we don't have any metadata, so we have no idea what information is actually associated with that. So this is a really cool part of Pinecone, is you can add metadata to the vectors. This is a feature that's totally missing from OpenAI's own kind of vector store. So if we cancel out of that, let's just delete that vector for the minute, and then back into here, back into that upsert vector, and then under metadata, let's add an item. And so let's put in content, for example. We'll put in a string, and we'll load in the value that we sent to OpenAI to create the embeddings in the first place, which is this full record. Now, we could send in the JSON Safe string or the full record. It actually doesn't make a difference here, because once we put in the full record, this module will make it JSON Safe anyway. So that's that one there. I'm going to load another one, which is title. So this is the title of the page. Nice to have this as a kind of a separate field, and that's the title there. And then we'll click OK, save it, run it again, and now that should automatically upload. And now you can see there's the values, the vector values, and now we also have the full content piece for that row. So they're the numerical representations of that content, and we have the title. So there's one other thing missing, which would be great if we're trying to identify if something has changed or not, which is it would be nice to create a unique hash of this content. So let's say that you wanted to keep this knowledge base up to date every day or every week, for example. And let's say you have hundreds or thousands of pages. Well, one option is you just load up your sheet every time. And with that upsert feature, it's going to update the record hundreds or thousands of times, even though nothing has changed. So an alternative approach is that you create a unique hash of the content. And then if nothing has changed, when we carry out a comparison, it's just going to skip upserting that. So it'll only actually upsert if something has changed. So to do that, then back into make.com, we'll click on upsert a vector. We'll create another metadata item here, and we'll call this unique hash. This can be of type string. And we're going to then use a feature here, which is the SHA-256 algorithm, which you can see there. And what we're going to do is pass the full record into that encryption algorithm. So back into the star, and we'll find the full record. This will make sense in a minute. So I'll press OK to that, and let's run it again. So that has now run again, and this unique hash should magically appear. Yeah, there you have it. There's a unique hash. So it begins with, 5F8D. If I run that again now, let's say a week later, I try to update that vector. As you can see, it went straight in to upsert the vector. If I refresh the page again, it's still going to have the same unique hash, 5F8D. So nothing has changed on that page. It's basically updated it, even though it didn't need to be updated. So what we can do then here is we can carry out a check on this filter. So if we come in here, stretch it out a bit, and we'll add a filter condition. So the label that we can add here is if the vector doesn't exist or if the page has changed. So first one then, from this module, if the vector ID does not exist, because here what we're doing is we're searching for a vector with that URL. If the vector doesn't exist for that URL, it hasn't been uploaded in the first place. So that's a perfectly valid condition. And if that's the case, we want to insert it. Whereas here, we're going to add an OR condition. And if that unique hash that we created is not equal to a new unique hash that we create, so say SHA-256 full record, then in that case, we also want to update it. Because if the unique hash of the Pinecone record is different to the unique hash that we now just generated from the text, it means it's changed. So press OK to that, and we'll click Save. Let's run it again. And now what you'll see is it hasn't passed this piece. Because if you look here, the vector ID is /about us. So the vector ID does exist, so it hasn't passed that condition. And the unique hash for that is the same because the content of the page hasn't changed. So now if we come into here, and if we just make any modification to this record, and we run it again, you'll see it's now going to flow through here because something has changed. And if we come back into here, this 5F8D hash, if we refresh it, we're now going to get something different. Exactly, now it's E7ED, and then you can see the change, content page, and then whatever text I just dropped in there. So that unique hash is directly related to all of the text that's on that page. Great, so that is the scenario. So let's just rename that to upserting vectors into Pinecone, and then we can let this one loose. So let's just delete that vector that we just created. And now if we change this to A2 equals M51, we're going to upsert all of the records on this Google Sheet into our Pinecone index. And then the next scenario we create will actually be to retrieve relevant vectors when generating outputs. So there's the A2 to M51. We have an empty Pinecone index. And now we can click Run once. And that is just going to bulk process through every record, as you can see here. It's cycling through all the numbers. And if we come in here and refresh, all of the vectors are now being uploaded into the index. Excellent, and it's finished. So that's 50 records uploaded into Pinecone. And there we go, record count is 50. And that's exactly what we have on our Google Sheet. Excellent, so next up, let's create a new scenario where we can now retrieve these vectors. So back into scenarios, new scenario. What we're going to do is use the exact same Google Sheet, but we'll have a new tab, which you can see here, which is articles. So I want to generate articles within this tab based on this title. I want you to write an article about an upcoming sale for our leisure company Luma. The sale is 20% off, and I want information on delivery and returns policies to be included in the article. And actually, I'll even change this because we have product information within this. So yeah, let's say that the yoga brick and the Summit watch. Make sure to feature the Sprite Foam yoga brick and Summit watch, as they are the focus of the campaign. Of course, this could have a huge amount of kind of style guides, tone of voice, etc. This will do for the moment. And so this is the article title or the description. And then I want the generated article to populate out here. So then back into our Google Sheet, you could use a watch new rows here. I'm going to just use the same get range values just to demonstrate this, but you could definitely watch new rows and have this scheduled to auto-generate articles. So then back into that Knowledgebase sheet, and we're going to use the articles tab. We'll put in the range, which is probably A2 to B2, I'd say. Perfect. So we'll press OK to that and save. Just run that scenario, and then, yeah, you can see that you're getting your full description here. So now, if we were to generate an article off the back of this, without any of the information in the knowledge base, we can demonstrate that here. So we'll go into create an OpenAI module. We'll use GPT-4o. We'll add a couple of messages. So one will be the system message, which would be write an article based on the provided text. And then the text would be a user message, and that'll be what's in that article description field in the Google Sheet. We'll set max tokens to 0, press OK, and let's run it. And like, this isn't really going to work. ChatGPT will generate an article, but it doesn't know anything about the products. It doesn't know anything about the store or its policies. So this is going to be generic, or even worse, hallucinating. So here's our result. And yeah, it has featured the products, but it knows nothing about them really. So it's just hallucinating kind of information about those products and hallucinating information about kind of returns policies and delivery information. So now what we need to do is let's ground this response with information from our Pinecone vector database. So the first thing we're going to do is have an LLM call to digest the article description. There's a lot of information there. And then we need to digest that into a search term to search our vector database. So essentially what we need here, delivery, returns, policy, and then the names of the products. That's kind of what we need to extract from this. So let's right click here. We'll add a module, say that's OpenAI, create a completion. We'll choose GPT-4o again. We'll set a system message. And that system message will be your task with writing an article based on a given description. Before writing it, we're going to go to our knowledge base to fetch relevant content that'll help ground the article in facts. Please propose a search term to search our knowledge base. And we're going to ask it to respond in JSON. So that way we're just going to get the search term and we're going to get it in kind of a variable that we can then use in the next module. So then add a message user, and that user message is going to be the article description. Max token 0, and we're going to ask it to respond in the JSON format. And we want to parse that JSON response as well. So we'll press OK to that. Again, let's do this trick of when 1 equals 0, because we don't need to generate the article because we still need to fetch everything from Pinecone. So we'll save that and run it. And then you can see the response in the bubble. And then the result is Luma, leisurewear delivery and return policy, and then the names of the products. So that is excellent. And that perfectly kind of summarizes exactly what we need to search the knowledge base for based off this description. So next up, we now need to create an embedding of this search term. We need to go back to that embedding module and generate vectors or numbers that represents this information. So then we can go to our Pinecone vector database and say, okay, here are these numbers. Provide all of the vectors that are similar to these numbers. Because if they're similar to these numbers, or if they're close to these numbers within the algorithm, it means that they are semantically relevant or they're highly related. And that's essentially how vector database and vector search works. So we'll come in here. We're going to go and add a module. This will again then go down to this make an API call. You can copy this out from the previous scenario, but it's /v1/embeddings. And then we're going to post to that endpoint. And then in the body, we are going to send the result from this module into that text embeddings 3 small model. So we'll press OK to that. So now we'll save it and run it. And it creates the search term, and then it creates the vector embeddings for that search term. And there you have it. You can zoom in there. So these are all of the numbers that semantically represent this search term. So we now have something to go to Pinecone with to get highly relevant results back. So we click on the dots, add a module, and now we're going to go to Pinecone, and we're going to use the query vectors module. Let's drag that over there. So then for vector, you can add an item. And again, turn on this map feature because we're going to send an array of vectors that we just got back from the last module. And then you can come into here, data embeddings, and click that. And then if you scroll down under include metadata, we definitely want to say yes, because we want to get the actual text back. We don't need a whole node of numbers that we can't use anything with. We need the text that's related to those numbers. And then under limit, well, we might just set that to, let's say, 4. So this is the number of results that we're going to get back from the vector database. And we'll click OK to that. So we'll click save. Oh, I need to move this filter again. Press OK to that. And then we can run it. So there we have it. We've gotten back, I've updated the result to 10 rows, and we're getting the Sprite Foama Yoga brick, and we are getting the Summit Watch, I believe. Yeah, Summit Watch, which is there. So they are the focus of the article. Then we're also looking for information on delivery and returns policies. So yeah, we're getting events and community. We're getting the homepage. Customer service, we'll have some of that. FAQs will also have some of that. So that pretty much covers off those kind of use cases. So within those kind of top 10 results, we are hitting everything that we need to hit. As you can see, the vector database is definitely returning relevant results, but in a lot of cases, the results that are at the top might not actually be the most relevant. So it's common to have what's called a re-ranking phase after you get results back from a vector database, where let's say these 10 results are then re-ranked based off the search term using a different model to then provide the absolutely most relevant results at the top. I'm not going to do that in this, just not to overcomplicate it, but you could definitely have a kind of a re-ranking module here. So the next module we need is an array aggregator, because what we're getting back is a number of bundles. So if I was to continue this on without aggregating those bundles, we would end up generating 10 articles. So if I click add a module and then just type in array, there's array aggregator. So we'll drag that over there. And what we want to aggregate are the bundles in this module. So we can just choose that module. And let's aggregate both, let's say, the vector ID, which is the URL, as well as the metadata, which contains the content of the pages. So we'll press OK to that, and then you can see that's grayed out because that's a little loop that's going to run, and it's going to kind of create bundles and then reduce down the bundles into an array. Then we need to transform that array into JSON so we can then feed it into ChatGPT, or you could use Claude, for example, to generate out the final article. So right click again and add a module. So it'll be transform to JSON is what you're looking for. So we're going to, transform this array. So we'll press OK to that. And now let's put in the filter again here. And now that has completed. And then you can see we now have a full JSON string, which is essentially everything that has come back from that vector database. And that's now what we can send into ChatGPT to augment the generation of this new content. So then let's remove this filter. We're in the home straight here. This was the module to generate the article. But now we can say, write an article based on the provided text while using the following information to ground the article in facts about the online store. And then we can just drop in relevant knowledge base articles, and then that can be the JSON string. You can also say only use information that is contained in the article description in the provided text by the user or the below knowledge base. We're going to press OK to that. And then finally, we'll just add one more module, which is to go back to Google Sheets. That is to update a row. Actually, we can use update a cell. We have the row ID from the first module. So we can choose our spreadsheet again. We can choose the articles tab of that sheet, and then go back to the first module. We have our row number, and we know what the cell column is, which is B. So it'll be B2, for example. And the value will be the results from this module, so our full article. Excellent. I think we're ready to run this flow end to end now. So let's click run. Goes to Google Sheets, gets the article description, and then embeddings of those search keywords are generated using the embeddings module, which is then sent to Pinecone to query kind of relevant similar vectors. And then the content related to those vectors is aggregated into kind of a string, which is then used in the article generation prompt to really ground the LLM to produce kind of accurate, personalized content based off the description. And it then saves that to the Google Sheet. So then let's go back into the Google Sheet. And we now have our generated article. So let's have a look at it. Excellent. So we have information about our featured product. We even have the image, which is great if this was going to be used on the web. And while we're reviewing this, let's open these up. So the Sprite foam yoga brick, normally priced at $5, it says. So let's have a look. Yeah, that is correct. 6 inches by 9 inches. I'm just kind of fact checking some of this stuff. Yeah, 6 by 9, you can see there. So it's very much grounded in the information on the product, originally priced at $54, and there's a 20% discount, which is accurate. So there's the $54, the whole 20% discount. That's the whole purpose of this article. And then standard shipping and priority, 5 to 7 days is $16. Let's have a quick look at our delivery. 5 to 7, yeah, $16. This is perfect. 2 to 3 business days for priority, 2 to 3 business days for priority. So that is absolutely ideal. It even mentions the gift card, and for more information, hit there. So that is a brilliantly written article in the sense that it's perfectly grounded in the information of the online store. Of course, you know, the style could be changed. You could put in a style guide for that article. You could use markup and then auto post that to WordPress or generate kind of social media posts off the back of that. But really what you're seeing there is how to really ground an article in company specific knowledge using Pinecone, using vector embeddings to really produce something that's pretty useful. And as I mentioned, a lot of companies are looking for this kind of RAG style system because it's not enough to get the generic text that's generated by large language models. They need company-specific text based off what's in a knowledge base. If you'd like access to these Make.com blueprints so that you can quickly import them at the click of a button, such as pressing import blueprint there. And as I mentioned, there's 2 scenarios. So this is the generation scenario. This is the upserting scenario. And then check out the link in the description to the community that my brother Alan and I run, where we can help you automate your business like a pro. We have weekly workshops. We have lots of course material, lots of templates to play around with. So check out the link below. We'd love to see you there. Thanks for watching, and I'll see you in the next one.